Welcome back to Minds Matter, a podcast sponsored by the Monash Centre for Consciousness and Contemplative Studies. I'm Beth.
And I'm Ava. And on Minds Matter, we explore research from neuroscience and psychology while occasionally talking through our own personal experiences.
And this week on the podcast, I spoke to Dr. Abhilasha Ravichander, who is a postdoctoral scholar at the Allen Institute for Artificial Intelligence. We kind of had a general episode on AI. So we spoke about what even is AI when we're talking about, is it just large language models? Are there different kinds of AI? We spoke about what are the exciting things to look forward to with the future in AI, some of the things we should look out for, the age-old question of will AI be able to become conscious? So I think this is a really good overview, and I hope you guys enjoy.
I'm Abhilasha Ravichander. I'm a postdoctoral scholar at the Allen Institute for Artificial Intelligence. And I received my PhD from Carnegie Mellon University in language technologies, which is kind of the study of how machines can automatically process language. Now such machines are all around us, like with Alexa or Gemini. But actually the models that underlie these systems, they're really opaque. So my research is focused on improving the reliability and transparency of these systems. So I study what kinds of mistakes these models make and where things break down. What are the likely fundamental reasons for those mistakes, and how insights from doing this process can inspire the development of future AI systems.
So cool, and obviously so relevant. So when we talk about AI, what is it that we mean? So you just mentioned Chat GPT and Gemini and Alexa. Is it these things? And are there differences between different types of AI, or is it just these large language models?
Yeah, that's a really good question. So the definition of what is and isn't AI is a little fuzzy. Broadly, I'd say that it's any system that automates activities that we associate with human thinking. And this could be like translating between languages or reading a document and answering your question. So you might also hear the term machine learning, which very informally is about giving a computer program the ability to learn from data and improve its performance on doing some of these tasks. So actually, in truth, nowadays, a lot of these terms are used pretty interchangeably, and the boundaries between things have become blurred. AI systems have also changed a lot. So it wasn't always large language models. So originally, people used to come up with a lot of rules and formalisms that were based on how humans would solve tasks. And we have moved from that to more statistical and data-driven approaches that compute like a lot of statistics and patterns over data. And now we're at large language models. So your question about are large language models the only models for language tasks? Right now, they're pretty much the winning paradigm. We don't currently have other approaches that work much better, but that's not to say that that's not a possibility in the future.
That's so interesting that the definition of AI can change. It's interesting that, what encompasses that changes. And I think people listening will be surprised by that, because it feels like it's such an important term that it would just be this one clear concept. So I think that that's really interesting that it changes. So it's changed throughout history.
Yeah, especially now that we have these kind of more general purpose models, we've stopped thinking of like making a model that does this specific thing. It's now models that, you can then specialize to do a lot of different things.
Yeah, so interesting. So then how does AI, or how do these models, how do they learn?
Yeah, great question. So modern large language models learn from data that's created by humans. So how these works is that these models basically process like massive amounts of text data, usually from the internet. So this could be things like books or scientific papers or Wikipedia articles. And the model is supposed to learn connections or patterns between the words in this data. So concretely, like how this is done is usually just by learning to predict the next word in a sentence. So for an example, if you see a sentence like, the cat chased after then we would make the model predict the following word in the sentence. And if the word that comes there is mouse, the model becomes better at associating cat and mouse with each other. So it learns something about the context these words occur in, and this process is done at scale over trillions and trillions of tokens. And now this process is usually followed by some kind of fine tuning stage where the model is more specialized at doing the kinds of tasks that humans are going to use the model for in practice.
So when we're typing into Chat GPT, so I guess this is the process that's happening. It's predicting the words that are associated with it. Is that right? Is that the right way to think about it?
Yeah, kind of. So these are generative large language models. So they are based very much on doing next word predictions.
Cool. So the next question is, and obviously this is a question that a lot of people are talking about in the news, and it can be a bit overwhelming about what's really going on. But what are some of the concerns about AI, and what do you believe are the biggest concerns out of the concerns that there are?
Yeah, this is a great question. And I think this is super important to address now because now we have AI systems that are actually going out in the public world. And many of these concerns are real life downstream consequences. So I think the biggest concern that I have personally is the lack of transparency surrounding large language models right now. So now that LLMs have become so profitable, there's a lot of commercialization in this space. And that means that people are very reluctant to disclose things like what data they trained on or what model they're using. And not only does this limit our ability to actually be able to inspect or audit these systems from the outside, it's also a major roadblock to science, right? Like, how do we even know what system we are studying if it can change 3 days from now and we have no idea that it changed? So I think this fact that there is so much power associated with large language models and all of it is concentrated within a few tech companies is really fundamentally bad for science. I think there are a lot of other concerns that people have right now. So I think one of the big concerns is that people really want to know how their data is being used to train these large language models. And there are a lot of reasons why people might care. Maybe the data is sensitive, or maybe they want to be able to update the data and not have a large language model, have a certain view on them forever. But currently, there's no effective way to know what training data was actually used for training these commercial models. Another big concern, I would say, is that these models can fail unpredictably. So when you deploy them, you don't really know when and where they're going to fail and how bad the impact of that failure can be. And so the fact that they're still a little unreliable is a major challenge for whether you can deploy them in some practical or sensitive setting. Another major concern, of course, is that when we start leaving decision making to these models, or even when you have models that are interacting with real people in the real world, there's a major risk of unfair outcomes and bias that these models process different people's inputs differently or make decisions about people differently. And I think another major concern is probably the environmental impact of these models because they require huge data centers and large amounts of compute to both train, but also to keep running. And all of these issues are things that we have, just started studying because these models got really big in the last 2, 3 years.
So with the lack of transparency, and I totally understand how for science that's, yeah, like, I mean, how do you study something if you're not given that information? I can't imagine. Do the companies have that information, or is it that the companies aren't communicating with scientists? Is it that we don't really know? Like, what's going on there?
Yeah, that's a great question. So if we take, say, training data, for example, the companies do know what data they train the model on. But actually, even internally, when you have data at this scale, it can be very hard to make sense of the data, even if you have access to it. So the first step is that no one outside the company has access to it. And this is actually really problematic because there are a lot of questions that the scientific community would ask that maybe the company itself is not incentivized to. But then, even if you have access to it, we are just starting to build tools that allow you to start making sense of what's in that data and how it might influence what your system is doing.
As a solution to this transparency problem, do you think there'll need to be regulation? What do we do to overcome that?
Yeah, so one of the big current efforts that we're doing is actually trying to build open source models that can match the performance, at least, of these proprietary models that, release many aspects of how they were trained and how they were evaluated. So one of these efforts is from the Allen Institute for AI. It's called Olmo, and they release everything, including the training code, as well as a search tool over the training data to make sense of the pre-training data. So I think the open source community has a huge role to play here. It would be great if there was some regulation at the minimum to, protect data contributors' rights. But right now, I'm not a legal expert, but we're not really seeing any move towards that kind of regulation. And without that, companies are going to do what they can to preserve their competitive advantage. So I think the push for a more transparent ecosystem is really going to come from the open source and the research communities. It would be great to give these communities more resources because it's really a bottleneck in trying to build these kinds of open systems. And academia does not traditionally have access to resources at the level of industry.
Yeah, because I was going to say it's so interesting as a scientist. I feel like nowadays, if you're, publishing papers, if not everything is open source and available, and if you're not doing that, it's not great practices. So it's so interesting. And then we have this whole new thing developing that's not open source. I mean, it just, from our philosophy and science, it just feels crazy. Like,
Yeah.
well, now on another side, what do you think then will be the biggest benefits of AI?
So I think the models we have now, they're really, really good at extracting patterns from data, right? And at a scale that no human could ever hold in their head. So I think we're going to see a lot of applications of this kind of ability. So we're already starting to see some applications in like drug discovery and protein folding where AI can synthesize new proteins, where the search space was just really hard for humans to completely explore. In our lifetimes, I think we have already seen translation, which I think is just one of those breakthrough AI technologies, just being able to address this language barrier that we have automatically has been extremely groundbreaking, I think. Personally, just in terms of the AI we already have, I'm pretty interested in assistive AI technologies. I don't know if you use this, Beth, but for example, I use GitHub Copilot a
Yeah,
lot.
yes.
Yeah, so I think right now the models we have are so good at reducing effort, which is kind of tedious or time consuming for humans. And they're also good at processing large amounts of information and extracting insights from it. So I'm really excited about there are all these like walls of text online, for example, like, terms of service documents and things like that. So I'm really excited about the potential of AI to read or process things that I should be reading, but I wasn't going to anyway.
Yeah, that makes sense. So I think lots of people would have heard about the Turing test. Can you explain what this actually is and what, if you think in the debate, if it's been passed yet or not at this point?
Yeah, great question. So the Turing test was this thought experiment from Alan Turing, who's this hugely influential figure in computer science. So basically, it was supposed to be a way to evaluate a machine's ability to exhibit intelligent behavior. And the idea is that you have a human evaluator, and that human evaluator is going to have conversations with human and conversations with a machine that's designed to generate human-like responses. So this judge would know that one of the two participants in the conversation is a machine, but not which one it is. So the machine can pass the Turing test if the evaluator cannot successfully distinguish who's the human and who's the machine. So a lot of people say the Turing test is asking the question of if machines can think, but it's actually more of a thought experiment, and it's addressing like a more subtle question, which is, can machines produce outputs that mimic a human and appear to exhibit intelligent behavior, which is appearing to think is very different from actually thinking. So consequently, a lot of people will say that the Turing test has been passed at this point and that chatbots can be good at mimicking humans. And I've actually seen some people take this argument to the extreme. So they'll say that machines have surpassed human intelligence in many ways. So they fail the Turing test because people recognize that, oh, this system is way too knowledgeable to be a human. But I think actually there's a larger debate about the validity of the test itself. Like, does passing it mean that machines can think or just that they can approximate what human dialogue is like? And there's a lot of nuance here. So the success of this test depends a lot on who the judge is and what kinds of assumptions and beliefs they're bringing to the table. So supposing one is unfamiliar with large language models and how they work, they might assume that good questions are asking LLMs about their first relationship or their fifth birthday party because models can't have these experiences and humans can. So, surely, if you ask it, you can distinguish between the two. But without filters, large language models are so good at generating these kinds of experiences. And maybe they can be even more coherent, fluent, and detailed than humans can. So, this is actually a really bad question for this test, but it would appear on the surface as a good question to maybe someone who is not fully familiar with how large language models work. And so I think that's kind of the heart of this, that humans can convince themselves that a LLM is a human.
We spoke to someone else on the podcast, Anil Seth, and he said one of the issues is with like Chat GPT and stuff is the models are being programmed to convince us that they're human and thinking, but like that's just part of what they're kind of aim. And there should be more transparency for them it to be clear that they're not, so we don't get kind of tricked into this feeling, if that makes sense.
100%. They're amazing at generating human-like text because that's what they're trained to do. It is heartening to see that like most large language model providers are trying to catch this and encourage users to, if you ask, say, GPT-4 about its fifth birthday party, it will say, oh, I'm an AI language model. I don't have birthday parties. So that is encouraging.
Speaking about these large language models so far, I think lots of listeners will be like, oh, this is so far from a human. But a lot of the conversation at the moment is like AI is going to become conscious. And from what we've spoken about so far, I think it would be like, oh, well, how would this produce consciousness? What do you think about that debate? And if AI did become conscious, how would we even be able to tell?
Oh, I would love to hear your perspectives on this as well from like the neuroscience perspective, because I think first, like, what is consciousness, right?
Yeah.
I think when people are talking about consciousness, they're thinking about AI having a mind in the same sense that humans have minds. And that means it's aware of its own existence and has thoughts and feelings. So I think where some of these people might be coming from is that in the last 5 years, we've kind of seen exponential progress in the development of large language models. So I think it might be natural to kind of extrapolate from, the kinds of systems we've seen to the kinds of systems we will see in the next 5 years. Yeah, at this point, I don't know if this is the right time period to be discussing this particular question, just with where systems are now. But this has kind of captured people's imagination, I think, because we're all always thinking about the future and what that looks like. So within our field, there's a lot of research on what will happen if AI systems try to deceive people. And all of these things kind of assume some kind of internal motivation or set of beliefs of a system. And that I would say having your own goals and desires is probably part of consciousness. At the same time, if you prompt a model to solve a math problem and it doesn't get it right, but then you prompt it again and say, oh, you are an exceptionally brilliant mathematician in the style of Ramanujan, and then ask it the problem, it does get it right. So there is
Why
some,
is that?
we don't know, but you
What?
can, yeah.
Oh my gosh.
Yeah, prompt engineering is wild right now. But I believe you can steer these models to some set of consistent kind of directions. So the truth is probably somewhere in between. Personally, I don't think that the consciousness question is an important research question right now.
I feel the same thing. So, as a neuroscientist, and I mean, obviously, that people hold all different beliefs, but and also I'm trained as a biologist, so I definitely have this feeling that consciousness is tied to a living system. And have this thing that the more I know we don't know anything. Like understanding consciousness, when we'll understand what it is I don't know if we ever will, but I do think that that is tied to a living system. How that looks and what that means, I'm not entirely sure, but I feel like AI won't develop that unless it somehow we get to this future where they become living systems. But I'm not sure. But that's from everything I understand, it doesn't feel like that's a worry. I think there is a worry if we think it's conscious and it's not. Like that I can see being a worry.
I
Yeah.
agree. So having that perception is worrying. And then I think there's a lot of downstream discourse of that, like about robot rights and protecting robot agency, which it's really good to have the research community focus on different things, but it's really bad is to put all of our research eggs in one basket. So if these directions get very outsized funding or community effort, that would be problematic, I think.
And I think some of these things like AI consciousness, I don't know, plays into a lot of, I guess, fears we might have. So you can see how those things maybe get the most, they can be from the public eye, like, oh my God, yes, we need to understand this about the robots. It's in movies, it's in all this stuff. So I think it's important thinking about funding, like what are the issues that we're actually facing. So now we're going to switch to some of your own work. So some of your upcoming work looks at hallucination in large language models. Can you tell us more about why this is a problem? And also, when you say hallucination, is this the same hallucination as we think of in humans?
What is a hallucination you think of from like a neuroscience perspective?
So that would be like a visual hallucination or a sound hallucination. So when you see or hear something that isn't there. So it's like it
Ah,
might be a symptom
mhm.
in psychosis.
Yeah, so this is a term that's borrowed from that, I would guess, but it's actually a little different. So when people talk about hallucinations with generative AI, they're talking about when the model presents some incorrect or misleading information to the user and they present it as fact. I think many people think of hallucinations as unavoidable because we often ask generative models to be creative and make up things, like when you ask Chat GPT to write a poem. But actually, a lot of people are using these models to get information now. And if you ask it for some factual information, you expect correct information. So I would say that this is not a problem in situations where humans already either know the answer to the question that they ask, or if verifying the model's answer is really easy and a person's willing to put in the effort to verify it. But when somebody's searching for information online, it's typically not because they already knew it. So an example of a hallucination might be like if you ask ChatGPT, when did Barack Obama meet Mahatma Gandhi, it might just hallucinate an entire example of that event happening. I can't talk too much about the unpublished work yet, but what we are trying to do is basically analyze how much this kind of hallucinatory behavior happens in very diverse scenarios. And we're trying to figure out why models hallucinate. So, for example, yesterday I saw that someone searched, how do I make the cheese stick to the top of my pizza and not slide off? Very valid. And the AI assistant suggested mixing non toxic glue with the cheese so that it would stick to the top of the pizza.
No.
So at first, when I saw this example, I thought this was because, oh, this model might not be understanding language. So if it saw stick, it associated glue and it didn't know. But then someone actually tracked down a post on Reddit where somebody had asked the question, how do I make cheese out of a pizza? And a user had very sarcastically posted, oh, just use some glue and mix it.
But it doesn't understand sarcasm, I'm guessing.
Yeah, and
Yeah.
it didn't understand the context. So I think if we start going deeper, we'll actually be able to understand where a lot of the problematic behavior of large language models come from.
That's so interesting. Yeah. It's training on human data. And we also have this thing where lots of things we say with a lot of conviction and that and that we're right, even if we're not. Could it be it's picked up on that too, maybe?
100%. The internet is big and there's all kinds of content over there. And the model can't differentiate between what we mean, and it's just looking at words without understanding the broader context beyond it.
That's so interesting. Okay. Everyone should take note of that. So your work has also looked at common failures of LLMs. Could you describe some of these?
Yeah, so a lot of my research has focused on identifying problem areas for LLMs. So broadly, I've been looking at, trying to measure undesirable things that LLMs do, which we don't want them to do, like hallucination or picking up these unwanted patterns from the training data. But I've also been working on measuring desirable behaviors or skills that we want models to have, such as making common sense inferences or being consistent. So I think we have found a lot of these kinds of gaps that are pretty consistent across models. For example, models are actually very inconsistent in their predictions. If you ask the same question in 5 different ways, it's very likely you'll get 5 different answers. Similarly, models can generate text. So if you ask them to, say, generate a story about 5 cats or something like that, they could generate a really nice story. But then if you ask them, oh, how many cats were in this thing you just generated, they wouldn't know. So there are lots of disconnects between what we think models should be able to do and what they actually do. And this kind of speaks to this more fundamental disconnect. So actually, a lot of things that are really easy for humans, like, for example, being consistent or, maintaining coherence across a long conversation that you're having with your friend, these kinds of things are really hard for models. And vice versa, things that models are good at, like, multiplying ridiculously large numbers, are really hard for humans. But when we are trying to evaluate AI systems, we typically think of things that humans are good at. And when models seem to surpass that ability, we'll be like, oh, they're at least or even better than humans. But the truth is that the things that we can do are different from the things machines can do. Another big problem that's kind of interesting right now in AI evaluation is that, remember how I mentioned that these models are trained on internet data? A lot of test sets for evaluations are actually released on the internet. So oftentimes the models might have already seen all the answers. And when we test it again, we might be looking at really good performance. And like I mentioned earlier, it's often hard to make sense of the pre-training data. So even if we had access to it, it's not super trivial to check whether the test set was in it or not. So this is another direction that I'm starting to think about, which is our data contamination and how we can fix this problem with how we're evaluating AI systems.
It's so interesting with the consistency that obviously humans like that, we're great at holding long conversations and remembering what's going on, and that's how we communicate. And to think about that these large language models can't do that. And then there's other things they are really good at. And yeah, the things that we're good at, like, oh my God, they're better than us, they're taking over. It's but then consistency and being able to remember what your friend said 5 minutes ago in a conversation is very important.
Yeah, I'm super excited about these new kinds of evaluations that the community is doing, which is like more focused on how people actually use these systems. Because in the end, it's good to know what capabilities a system doesn't have and has, but it's also good to know like how practically useful the system is at combining these capabilities.
So your work also looks at using LLMs to help people discover how their data is being used. Can you tell us more about that and why this is important and how LLMs can do that? Which you've touched
Yeah,
on some of those things, but yeah.
for sure. So when people give up their data online, they're usually doing so under the terms of something called a privacy policy, which is a legal document that discloses how companies can gather, use, or manage user data. But these policies are typically they're really long, verbose, they're complex. I don't know if you've ever read one, but
I don't think I've ever read one.
I've clicked I agree a lot. I don't read them either. But there's actually a really good reason. So they're difficult for everyone to read and understand. It's not just us. And there was this study by McDonald and Crenor that found that if people were actually going to read the privacy policies of all the services they interact with every year, they would spend 300 hours per year just reading privacy policies.
It's crazy.
So the system's designed kind of against us, right? So in practice, users are never going to read these privacy policies. And so a majority of people care about their privacy, but it's basically impossible for them to keep up with how their data is going to be used. So a lot of my research has focused on using natural language processing to read these privacy policies for people. And this is something that's impossible for humans to do anyways. So more recently, I've also been working on building technologies that are more focused on helping people understand if their data was used to train a particular language model.
That's really cool. And I like this idea of thinking about how these large language models can help us with things that are impossible for us to do, like all this reading or these super complex equations. The things that they can assist us with that they are better than us for, and that's okay, but then they don't have these other capabilities that we do. It just
Yeah.
feels less this dystopian future kind of view, you know?
Yeah, I think there's so much potential in places where there's low cost of mistakes and where they're better than humans would have been otherwise.
Well, this was one of the episodes where I was basically like, wow, people are so smart and they know so many things. But I really liked when Abhilasha was talking about the kind of arc that AI has had over the course of the last, I guess, 100 years of like, at first we were trying to train it with these kind of if-thens and these rule-based ways of thinking about problems that was kind of in line with how we were thinking about problems at the time, and how AI has really evolved to be like feeding on itself in a way that definitely wasn't happening in the 60s when people were doing this more rule-based type research. And since we're both not experts, I think we both have kind of differing views of what we think about AI and where we think it's going. So yeah, what do you think, Beth? I know that you love Terminator. So do you think that's where we're going? And I know that you very strongly believe that consciousness has to be tied to life. So where do you think that AI is going, given how fast we've gotten Chat GPT 3.5, 4.0?
Yeah, so this is one of the things I loved about this episode was one of the things I feel that's hard to work out when you're reading about AI is all of this like doom. Oh my God, everything's going to be terrible. We're all going to die. Or like, oh my God, it's going to be utopia. And it's like, is that really what's going on? And it's so hard, especially because, I mean, probably these AI companies, it's in their best interest to put out information like that. And I always feel like, wait, is that really what's going on? So one of the things I loved about this was getting to the bottom of what's going on. And it doesn't seem to be like either of those possibilities. It's like some in between thing. Like most things, something's going to be good, something's going to be bad, but we should just keep an eye on it. But it's funny because I first got the idea to do an episode like this when I was visiting Ava. We were sitting in her lounge room. And I, for some reason, and I just never thought of AI that much or that like we had anything to worry about. And I don't know what I was thinking. I guess I just wasn't really thinking about it. And Ava starts telling me about how we have to really worry about like the end of days, kind of. Can you remember this?
No, I literally have no memory of this conversation at all.
Remember? And you're like, it's not that it will become conscious, but it'll be that like it'll get in the wrong hands. And
Oh,
then
yes.
I was saying to Ava, but wait, shouldn't we start panicking? And you were like, no, because there's nothing we can do about it either way. So we should just keep living like everything's fine. Can you remember that?
That sounds like me. I don't I don't remember this exact conversation, but I think in general I have like that's my general nihilistic perspective on things.
Yeah. And then I was like, oh no, do I have to be really worried now? And I'm like, oh no, Ava, do I have to worry about this now too? And
Are you worried?
no.
Okay, I left that free.
I was for a minute, and then I feel like conversations like with Abhilasha, it's like, oh, we don't need to worry.
I don't know about worrying. Maybe I'm more of like a doom person about AI. I feel like it's a bit like the climate. Like it's happening. The bad things are happening. Things are happening. Okay, it's not all bad things. I think some wonderful things are happening. I use Chat GPT a lot. It makes things so much faster. And I think it has the potential to basically free us as humans from like the boring stuff and like let us be creative. I think one of the dangerous parts is that I think more and more it feels like AI is doing the creative, interesting stuff and humans are not doing that, which I think is one danger. I do think that AI is super powerful and that, as you said, in some sense it's neutral, right? Like it's training itself, but we still ask it to do things. And it's not at the point where it's doing things on its own. Though, there have been like these scary case study things where people have tried to hack ChatGPT to like hack into itself and do things like that and do lots of scary things. And I have heard people say, because not all of it, but a lot of it is open source, that it's going to be pretty hard to stop a couple of the crazy people who are going to do crazy things with it. So things like that. And then I think that my thing with AI and tech in general is, and I guess this gets into consciousness, but I think that we're all just going to become like singularity. I think we're all just become one big mush of consciousness at some point.
What? You need to unpack that.
Well, I think that because, there's this framework in philosophy about, and I'm sure I'm butchering this, but about this idea of the extended mind. And that's existed for a long time, which is, there's this idea that the mind is in your brain. And then other theorists were like, no, it's in your brain and in your body, like this question of embodied cognition. So your mind doesn't end at your brain, which in some ways makes sense, right? Like riding a bike is something that you do with your entire body. It's not just something that you remember in your brain. But then some people have taken it a step further and have said, there's no reason to even say that your mind ends at your body, because a lot of the times when we're doing really tough cognitive tasks, even not that tough, like if you're doing addition, sometimes if you write it down, you do 18 plus 18, you carry the one, those types of things, you're doing that on paper. So in some ways that paper is part of your mind as well. And I think that's like getting very extreme even with Google already, but also with ChatGPT, right? When you're going back and forth with ChatGPT to try to get you to solve a problem, or even like more analog, like you do that with your advisor, you do that with your friends when you're trying to figure something out. Some people say that it's one mind in a sense when you're co-constructing how you're thinking about something. And I think with AI, especially, when we start getting those chips implanted into our brains, we're going to have access to so much so quickly that it will be hard to separate your brain and your consciousness from whatever you have implanted in your mind, which is like pretty close to what we have on our phones. It's just that it would be happening more quickly and neurally rather than just with your fingers typing things, which would just be a faster process of what we already have. But then at some point, I think it would kind of blur the lines between your thoughts and what you know and what the cloud knows. And I think if everyone is at that phase where everyone is getting access to similar information, then hive mind. I don't know if like robots will take over. I think that we will all become robots.
And do you see that it's happening in our lifetime?
I don't know, because I think I would have said no 2 years ago, but I was really shocked with how far Chat GPT came when it came out. So I would have
Okay.
said no, but now I truly don't know. And, you know, like you said, I'm along for the ride. We'll see what happens and no need to worry about it for now.
But so with this hive mind robots, you have to then be in the camp of embodied cognition, and not everyone is. So I think that's an important thing. So this idea that, you know, our mind is also the table or whatever, you have to be like in that camp of belief, and not everyone is. So I think that's important to say that that's not everyone believes that
Yeah,
this is the way the mind works.
that's true.
So
But I think, I mean, already people kind of have this idea that like in some ways it's becoming more apparent that our thoughts aren't our own, with the fact that just online we're in these echo chambers. And it's in a more extreme version of communities that we have in person. That like if your friends think in a certain way, that's going to influence how you think, but online that just is amplified. But I think then and you're still able to remove yourself from those situations, right? And kind of see the real world. Some people maybe less than others. But I think then if we're at a point where everyone has access to the internet in a second, so like you're not typing a question, right? You just think a thought like, what's the population of Portugal? And immediately it's in your mind and you have that information without actually having to search for it. Then at that point, I do think it's hard to say that the mind is just in your brain if literally the information that you have is automatically accessed through the internet or whatever cloud it is. And then I think at that point, it does become extended cognition in a more compelling way, maybe just by virtue of how fast the information would be. All of this is obviously just essentially like a Black Mirror episode or something, but these are things that I feel like we're going towards, especially with like the Neuralinks and like the chips and whatever.
Yeah.
Like that's what it seems like people want to do.
Yeah,
and it would be hard to fight.
I don't think I'll ever get a chip implanted, but who knows? But I really understand what you're saying, and it does all seem very scary. But what I guess I find hard is that if you think about what these large language models are doing, which is just like predicting words, that's not how we think. So I guess that there seems such a big difference between how we, as you know, the differences that we were speaking about, like it doesn't have this memory and it doesn't have this context and it can't work out sarcasm. And, you know, the way we think isn't just predicting. It's like we have a mass of words and we just predict the best one to say next. And I guess because the information is stored in this other way, it feels like it won't ever become one or whatever, because there's this big disconnect about how it comes about. Does that make sense?
Yeah, I definitely agree. Although I think that some people might argue that actually we are just, you know, predictive processors in a different way. I mean, it's just with the LLMs, it's really just language and predicting what's coming next in a sentence or in like a logic flow that you're building. But I think that a lot of people argue that we are like statistical machines and that we're just predicting the optimal thing that's coming next, including in what we're saying. And I do think that it feels like, I guess, you know, like the Freudian ego or whatever. There's like a me that has an oversight over what I'm saying, even if it's trying to predict what's coming next. But I do think that there is something to be said about maybe there is part of this like statistical way of thinking that is also ingrained in us. And like that's why we do what we do in some ways. So I think some hardcore people could argue with you about that. I don't feel knowledgeable enough to have that argument, but I do think there's something statistical in how we think. But then I also think even if the LLMs, and this obviously isn't the final form of AI, but I think even if the LLMs aren't the way that we think, if we got to a point where we could have constant access to an LLM at all times, then it doesn't matter if that's not the way that we think, because it would essentially be like a fusion between human and LLM, right? Which I think doesn't mean that we are AI, but like we become a different thing that's like still alive, but is still a different level of intelligence, because as you talked about in this episode, right? Like already LLMs are so good at doing some things that we're so bad at and that we physically are unable to do. And we can do things right now that LLMs can't do. And it seems like it's possible that we might fuse.
Okay, well, there's on that. So I'm really not convinced by this, but then what's the difference to when we're driving a car? Like, are we also the car? Like, I don't know. It just feels
Yeah.
we
I
are.
think some people might argue that we're the car.
Oh, okay. Well, then that's like, oh, well, we've achieved this merge of super speed.
I think so, right? I mean, I think it's also just like the context in which we use this. So I think it's easier to say, okay, like, and obviously this is all like if we were able to have a chip where we're constantly able to access the internet, which the tech there is also super far away. That's like completely different tech than AI. But if we were in that situation and we constantly had this chip, if instead of getting into a car, if we were always in the car, then we always would have the capability to go that fast. But it's just that we get out of the car.
So you think that then if we were always in cars, that would be a part of us?
Yeah.
That's funny. I guess I don't feel that.
What do you feel about your phone? How do you feel about your phone?
I don't feel like it's me.
I don't feel like my phone is me, but I think it's a fundamental part of how I think. And I think without my phone and without my computer, I would think in a very different way than I do now. And I think
guess
that would
that's
influence at some point, if we want to get into that, like who I am, because it's such an integral part of what I do every day and the way in which I process information.
Yeah, I guess that's true. I guess I need it to find everywhere I go. And I guess the problem with the chips would be who's going to so we're not all going to have access to them. So I guess the problem is going to be probably like the most wealthy, powerful people will have access to the chips, and then they'll have this ability to have more intelligent. Yeah, I guess that's probably the issue, right?
Yeah, I think that's just like the one potential world where it's the end of the human race as we know it, is like everyone has these chips that somehow are able to access all the information ever. And then, yeah, would we even want human bodies? Probably not. Anyway, that's a different discussion. This is just a sci-fi episode. But
if we're doing that, like we have poverty to solve. I don't know. I guess I see so many issues facing humanity at the moment. I find it hard
to believe that we'll ever get there.
Yeah. Does that make sense?
No, I think you're right. And I think that every time we have new technology that benefits people, rich people use it first.
Yeah.
In whatever ways, like lots of different types of technology, even plastic surgery. Like rich people use plastic surgery, and that just increases their influence and power.
True.
And I think that if there were something like this, I don't know. I think that's also an interesting discussion of like, would rich people use it first, or would they get assistants to use it to make sure that it works? And then we could have a Lucy situation on our hands. Have you seen that movie?
What's Lucy?
Oh my God. It's really bad. It's like, the premise is insane. It's a Scarlett Johansson movie. Shout out Scarlett Johansson. She's also in Her. She's in so many excellent films, some better than others. But Lucy is based on the premise that we of course all know as neuroscientists, that we only use 10% of our brain at once.
Mm-hmm.
And so it's about, that's not true. Yes, that's not true, as a disclaimer. And it's about what would happen if you used 100% of your brain.
What does she do?
I don't want to spoil it. I'll tell Beth, but if you don't want to hear this, skip ahead like 15 seconds. But basically at the end, she turns into a computer. She like becomes a computer. She literally builds herself into a computer and like disappears.
That's crazy.
Yeah.
No one worry about that. That's not going to happen.
Yeah, we do use 100% of our brains at once.
I guess the other thing I find hard with all of this stuff is where the tech actually at is so far from all of this. And although we're moving at a really fast rate, and I acknowledge that, the jumps in knowledge we're going to have to understand to go to these next extreme steps are massive. Will we ever be able to do that? I'm not even really sure.
That's true.
That's the thing I always feel like. I'm like, yeah, okay, we're moving at this fast rate. Oh, wow, it's crazy, whatever. But then if you think about what we're going to have to understand about the brain and the mind, and we're so far from doing that. I'm really sorry, but like, as neuroscientists, I think the thing we know is like, we don't really know much at all.
Yeah.
No one ever wants to talk about that. Like, we're kind of in the dark. I mean, yeah, we know something's going on, but there's so much stuff we just don't know.
I definitely agree. And I feel that I know nothing. But I also think that it's disturbing how fast and like how good these models that we don't understand are. And I think it's totally true. Like we right now are not at the phase where we're having chips being able to do much in our brains, where that's even safe. But it just feels like the jump in the last 20 years, as someone who is outside of this, was really not I wasn't expecting it to go that way. And it felt like for I guess like 50s to 60s, 70s, like when it was those if then like rule-based learning, that felt like it got nowhere. And then suddenly, it was like 40 years later we have chatbots, and then the chatbots can do all my homework. Like that was unheard of. So I think it's true that we're far from a lot of what I don't even want to call it intelligence, because I think a lot of these things are intelligent just in like different ways than we are, but like really scary consciousness. Like I think Abhilasha was right in that the question of consciousness is not the question to be asking right now for a variety of reasons, but I think it's hard to say it's not coming because
I don't know.
I think we just don't know. I think the best we can be is agnostic about what's happening. But I think if it were to come, then I think we will all become robots. Although I think some people might become robots before us. And maybe they will just want a class of like working underlords. What are those called? Not lords. Like working lower classes to make things. But then why would they use humans? So inefficient,
The other thing is sometimes when the tech companies put out these, oh my God, look what this thing can do. Oh my God, look what that thing can do. And it can look really scary and insane and like, wow. And actually it's very simple behind the scenes and not that impressive. That's what I want.
Like the Amazon grocery store.
That's exactly what I was,
Which was like Amazon had these grocery stores that seemed amazing, and it was like AI could track what you were getting, but really they were paying people in the global south like 2 cents an hour or something to just be tracking you all the time and just be looking at exactly what you were doing. So it was actually humans doing it with a lot of human power. But I don't know. I think maybe I'm just like still like naively in awe of what these LLMs can do, because I'm super impressed by them. I know they're fallible, but they're pretty damn good.
Didn't Amazon also do something like we can predict what you want? But basically it was just looking at brain activity in an MRI. It was just like looking at some brain activity, but it wasn't that impressive because we know that we can look at that already and say someone wants a drink or something. I feel like there was another sort of gimmick like that, like the reading minds gimmicks.
Yes. Yeah, and I think Neuralink has also been like, oh, look at all these amazing things we've been doing, and people in academia have done those things before. So I think that that's true. But I think, multiple things can be true at the same time. Like, I think it's super impressive where we've got, but I think you still need to kind of do your research about what is happening behind the scenes. And sometimes that information is just hard to find, which is maybe the biggest issue, which luckily Abhilasha is doing. But yeah, I think this is probably like the only, well, I don't know if you're more optimistic than me. I think this is probably the only thing where I'm like, yeah, I think we're progressing and we're going to get there. And like, it's probably going to be bad, but it's bad now. And you're like, oh no, nothing's going to go wrong.
Maybe I'm just in denial. Like in those books, the people who like never do the tech thing,
I just think I wish that we'll have this now, but I wish when we met, when you were like super depressed, I should have been like, what do you think about AI, Beth?
Be like, get me out of here.
That would have been your last straw.
Well, this has all been amazing. I feel like I learned a lot and it's super exciting. Do you just want to finish by sharing what you're excited about, what's coming up next, which I'm sure is a lot of amazing things?
Yeah, so personally, I'm really excited about having this era of greater transparency and control with the next generation of AI models. So I would love more disclosure and transparency into how these systems are being built. But I also think we can build more technology that helps us make sense of what these models are doing and also build tools that allow people to have a say in how AI systems are built and how it's going to affect them and how their contributions are used. And I hope to continue working on tools that allow people to have better control over whether their data was used in the model input, better control over what the model says about them, and also tools to help update models, because knowing your data is in a model is only half the equation. The other half is being able to do something about it. I think the community, and the really exciting direction probably for the next few years, is that we are kind of stuck in this kind of very scale based approach to developing AI models. So right now, the winning way of having a better model is, number one, identifying more and higher quality training data for that model. And number two, having a larger model on more GPUs. So this seems a little bit inefficient, and I think there are probably things to be done over here. Like, it's good for probably some of the community to keep working on scaling up and figuring out more efficient ways to scale up. But there might be other paradigms that we are not considering yet on how to make even better large language models. Yeah, and I think the third thing I'm excited about is probably applications of AI, because we've just started having really good AI models. And these kinds of developments are probably going to come not from the AI community, but they're going to be really interdisciplinary collaborations. So, yeah, super excited to see what people build.
Thank you to Dr. Abhilasha Ravichander for joining us this episode. Our intro and outro music is Nobody Stayed for the DJ by Glacio. Our transition music is Back for More, also by Glacio. Minds Matter is mixed, edited, and created by Beth Fisher, she's the Australian one, and me, Ava Madasuza. We'll be back in 2 weeks with a brand new episode, but in the meantime, find all our episodes and show notes on mindsmatterpodcast.com.